This is a follow-up to my previous lesson on understanding arithmetic sequences, and which also contains a couple of simpler examples. If you're finding the examples in this video particularly tricky, you may want to watch the previous video to see how the simpler ones work. So without further ado, let's look at these examples. So here's the first scenario. You've seen a smartphone you wish to buy, and the cost of the smartphone is £375. This is how much money you currently have, £35. And looking at your budget, you've worked out that you're able to save £18.50 on a weekly basis. The question is, how many weeks savings do you need to make in order to afford the smartphone? This problem can be solved by turning all of the details we have into an arithmetic sequence. The initial value in the sequence is how much money you have, which is £35. And because you'll be increasing that £35 by adding £18.50 and doing so every week so that the amount grows, the £18.50 acts as the difference in the formula, because the difference in how much you have between the current week and the following week will always be £18.50. And what we're trying to work out is how many times you need to add £18.50 to the initial amount to have the value £375. Here's what the first few terms in this sequence would look like if you decided to write them out. 35 at the beginning, then we're adding 18.5 each time. But we don't need to do this because we have the expression which can find the value of any term in the sequence. Let's start plugging values into the equation. I'll start on the right hand side. We know that a sub 1 is your first value, which is £35. That's how much you have at the beginning. Then we're going to add n minus 1 times the difference, and the difference is 18.5, £18.50. And we're trying to find the term which has the value 375 or as near as possible to it. And so that's the value of a sub n, 375. We're trying to solve for n because we want to know which term will give us 375. So we can subtract 35 from both sides. So 375 minus 35. And that's going to give us n minus 1 times 18.5. We can then get n minus 1 on its own by dividing both sides by 18.5. And the 18.5s on the right hand side will cancel. On the left hand side, 375 minus 35 is 340. So that's 340 divided by 18.5. And that equals n minus 1. And then we add 1 to both sides. So we get that 1 plus 340 divided by 18.5 equals n. And if you run those numbers through your calculator, you will get that n equals 19.38. I've rounded it up to 2 decimal places. Obviously there's no such position as 19.38, but what that means is that the position has to be greater than 19 in order for the value to be equal to or greater than £375. And that means that n must equal 20. Now the question is, how many weeks savings do you need to make in order to afford the smartphone? Now be careful here because you might be tempted to answer 20, but this is the 20th term, which is a sub 20. Let's plug this into the equation so we can definitely get the right answer. So n equals 20, so we have a sub 20 equals, well, a1 we know to be 35, plus n minus 1, well, n is 20, so that's 19, times the difference, which is 18.5. If you run that through your calculator, you will get that the term a sub 20 equals 386.5, which is £386.50. But that is equivalent to £35 plus 19 payments of £18.50, which means that the answer to how many weeks savings you have to make, it's 19 weeks. Let's move on to the second scenario. You're at home and you want to make yourself a cup of tea. Your kettle has a maximum capacity of 1.7 litres, a minimum capacity of 0.5 litres, and at the moment it only contains 0.2 litres because somebody didn't top it up after their last hot drink. In your area, the cold water tap runs at 0.15 litres per second, and the mug that you want to drink out of has a capacity of 0.6 litres. What's the maximum amount of time you can add water to the kettle so that it can boil safely? If you overfill the kettle and boil it, the lid may burst open sending boiling water everywhere. So when filling this kettle, at what time must you turn the tap off? Well, again, this is a problem that we can use arithmetic sequences to solve. This is because we have an initial value that we're increasing by the same amount each time. The initial value is 0.2 liters, which is the amount of water that the kettle contains currently, and we're increasing the amount of water by 0.15 liters each time, because that's how much the tap lets through each second. So in the expression for the arithmetic sequence, A1, which is our initial value, would be equal to 0.2, and then the difference, which is added to the initial value each time, would be 0.15. We can plug those values into the expression, and because we're trying to find out which term has a value that's less than or equal to 1.7, we can set the value of A sub n as 1.7 and then solve for n, and that will give us a nearby value. So let's plug all of these values into the equation. We'll start on the right hand side. So A1 is the initial value, which is 0.2, and then we're adding n minus 1, and that's multiplied by the difference, which is the amount of liters that comes out of the tap every second, which is 0.15. And then on the left hand side of the equation where we have A sub n, we're looking for the term which gets us around 1.7 liters. And now we can solve for n, which will get us our term. We can start by subtracting 0.2 from both sides. So that's 1.7 minus 0.2, and that's going to be equal to n minus 1 times 0.15, and then we can divide both sides by 0.15, divided by 0.15 on the left hand side. We divide by 0.15 on the right hand side. The 0.15s cancel on the right hand side, so we get that n minus 1 equals 1.7 minus 0.2, and all of that divided by 0.15. We can add 1 to both sides of the equations, but we can notice that 1.7 minus 0.2 is 1.5, so we can clean that up, and that's over 0.15, and then we add 1, and that is equal to n. 1.5 divided by 0.15 is 10, plus 1, and that equals 11, so n equals 11. Now, if we plug n back into the equation, A sub n, which is A sub 17, and that is equal to A sub 1, which is 0.2, and plus n minus 1, well, n is 11, so n minus 1 is 10, and multiply that by 0.15. Oh, and I forgot that A sub 17 is 1.7, which means that to get the kettle up to 1.7 liters, we have the initial value of 0.2, and then we're adding 0.15 10 times, which means that our tap is running for 10 seconds. So that's the maximum amount of time that we can add water to the kettle so that it can boil safely. I have one more question for this scenario. The question is, what's the minimum amount of time you can add water to the kettle, obviously, so that after you've had your tea, the next person will not have to top up the water? Now, this question seems a little bit tricky, but the first thing you can do is to remember that the capacity of your mug is 0.6 liters, and there needs to be enough water in the kettle so that after you poured water into your mug, the water in the kettle should be at a level that doesn't need topping up. So that has to be at least at the minimum level, which is 0.5 liters. And so you need to work out how much water needs to be in the kettle for that to happen, and how long the tap should be on to reach that amount. So let's say that the amount of water that needs to be in the kettle is X. The size of your mug is 0.6 liters, and after you've poured water from the kettle into your mug, that's going to subtract 0.6 liters from that amount X, and the amount of water left in the kettle should be no less than 0.5 liters. To get the value of X, we simply add 0.6 to both sides, and that's going to give us that X equals 0.5 liters plus 0.6 liters, and that's 1.1 liters. So that's how much water needs to be in the kettle so that after pouring your mug, the kettle doesn't need topping up. And now we need to figure out how long it takes to fill the kettle up to the 1.1 liter level, and we can use the arithmetic sequence for that. So we're looking for the value at the term A sub n. The value we want is 1.1 liters. A sub 1 equals 0.2 liters because the kettle is almost empty, and then we're adding n minus 1, and that's multiplied by the amount of liters the tap gives every second, and that's 0.15, We can subtract 0.2 from both sides, so that's 1.1 minus 0.2, and that gives us n minus 1 multiplied by 0.15 on the right hand side. The sum on the left hand side is easy to do, that's 1.1 minus 0.2, which is 0.9. And then on the right hand side we have n minus 1 times 0.15 again. We can divide both sides by 0.15, and on the right hand side, 0.15, the 0.15s will cancel, and then we get 0.9 over 0.15 equals n minus 1. Add 1 to both sides will give us n, so 1 plus 0.9 over 0.15 equals n. If you run 0.9 over 0.15 in your calculator, you get 6. So the left hand side equals 1 plus 6, which equals 7. So n equals 7. And now all we need to do is plug that into the equation. So we get that a sub 7, which is the term for the amount of water we're looking for, that equals 1.1, which equals a sub 1, which is the initial value. So that's 0.2. Plus n minus 1 times the difference. Well, n is 7, so n minus 1 is 6. And that's multiplied by the difference, which is how many litres of water goes into the kettle from the tap every second. And that's 0.15. But the part we need to focus on is that you have the initial value, which is 0.2 litres. And then you add 6 times 0.15 litres. And that means you'd have to have the tap on for a minimum of 6 seconds, so that once you've made your cup of tea, the next person will not have to top up the water in the kettle. So there you go. There's 2 examples of questions that you can answer using the formula for arithmetic sequences. That's it for now. Thanks for watching.